Okay, the main question of Chapter 7 is how much output should firms operating in a perfectly competitive environment produce? So it's product output decision, not the pricing decision. Let's look at the example given in the slide. So the market price per unit is $10. So total revenue, which you remember is price per unit multiplied with the quantity Q of output. And total cost here is given as 1 plus 2Q plus Q squared, quadratic function. And you can see that when quantity of output increases, as we have quadratic function with positive sign, the total cost will be increasing really fast. Therefore, profit pi equal total revenue PQ minus total cost. So we have this expression given on the slide. Okay, let's solve profit maximization problem as a manager whose total cost follow 1 plus 2Q plus Q squared and total revenue is 10 multiplied Q. And we want to find output of your product that maximizes your profit. So profit function here, pi, equal to total revenue, 10 multiplied Q minus total cost, which is 1 plus 2Q plus Q squared. So we have minus Q squared plus 8Q minus 1, which you can rewrite as minus Q minus 4 squared plus 15. As this is the negative term, by making it 0, you are maximizing. So we can conclude Q equal 4. Or if you are comfortable with calculus, some basic calculus, when you maximize or minimize your objective function, then you know at the maximum or minimum, the derivative or the slope of the function curve equals 0, which implies delta pi over delta q, which is a variable you can change here, should be 0. So when you apply basic calculus, let's say this one, then you have minus 2q. So this power comes down, right? And plus 8 from the second term, and constant doesn't change, so delta minus 1 is 0. So this is 0. Therefore, you arrive at the same conclusion. Q should be equal to 4. And then you can also figure out what's going on when you do this optimization by looking at the graph of total revenue, total cost, which is given in figure 7.2, and profit function given in 7.3. Figure 7.2 shows you total revenue and total cost curve. Total revenue, which is 10 multiplied Q in our case, is a straight linear curve as you see in blue ink. And total cost, which has plus Q squared, is quadratic term, so it is increasing in increasing speed. So as you see there, the total revenue minus total cost at each quantity of output, that's the distance between these two curves at each quantity of output indicate the size of total profit. And the difference is actually maximal when Q equals 4, as you see the dotted yellow line. And it indicates the distance or size of profit is 40 minus 25, that's the total profit. And when the firm moves away from Q equals 4, either decrease or increase the output, the distance between these two, which means total profit, is decreasing. And as you see, where the two curves intersect around Q equals 8, then total profit equals 0. And after that point, if the firm produces even more, then total cost is greater than total revenue, which means only loss occurred to the firm. What about the total profit function, which is the conclusion or the consequence of these two curves' interaction? If we draw total profit function, as you see in figure 7.3, then total profit, which is the distance between total revenue and total cost function in figure 7.2, will be increasing until Q equals 4, and then it reduces as you increase the output, right? So when the output is 8, total profit, the red curve on this page, equals 0, and the maximum or the peak of the profit reach when Q equals 4. And you can see that on the top, the slope, as is shown on the blue curve, or along the blue curve, the slope at the maximum equals 0, which is expressed as delta Q, change in profit over delta Q, delta pi over delta Q, change in profit over change in quantity of output. So there's a benefit if you know some basic calculus as well. And knowing the intuition along the graph is very important too. Thanks for watching.